So if we're going to find the equation of the line of the cubic, it's very similar approach to that again of the quadratics. Depending upon the form of the graph, that'll determine which form of the equation we take. So you can argue there's probably 4 different forms. The first of those, we're going to use this form here if we're just given the 3 intercepts. So in other words, if our graph, bing, bing, bong, if we have 3 different intercepts, we'll always need one other point. We're going to use that form of the graph, all right? If by chance one of the intercepts we got touch the curve and is a turning point, we're going to use that form there, B, because we know that's a repeated factor. So if that's 1, well, we know that that's the same as x minus 1 all squared, okay? Again, we're going to need obviously that point and some other point. If we don't have, if our graph is of the form of a form with a point of inflection, in other words, it might be something like that. I don't know, it could be the point 1, 2, or that point of inflection, that means it's cubed. And again, we've got some A at the front. If, on the other hand, and these ones are never much fun, we've got our graph and we just get, I don't know, 4 random points. In fact, we'll need, 4 random points, A, B, C, and D. So I need 4 bits of information. You're going to have to substitute each of the points in and then solve simultaneously. This method typically is using a CAS calculator. All right, so let's have a look. All right, question 14. We might come back to example 14. We'll do examples 15 first. All right, so let's just make it a bit more space. So what's the form of the graph? We can see here that our graph has got a turning point at 2 and an intercept at x minus 1. So that means my graph y is equal to, there's always some A for dilation. The minus 1 gives me x plus 1 as a factor. The plus 2 gives me x minus 2 squared as a factor because it's a turning point. So there's my general rule. And the point it goes through is the point 3, 2. So there's my x, there's my y. So 2 is equal to some A, 3 plus 1, 3 minus 2 squared. So we get 2 is equal to A times 4 times 1. Therefore, A is equal to 1/2. So my equation, 1/2 of x plus 1, x minus 2 squared. All right. B. B is that second to last one we were talking about. Here we've just got a point of inflection. Okay, now hopefully you're thinking to yourself, it's a negative cubic because of the area we're started. So my point of inflection, that means I'm going to start with some y equals some A. Now -1, so that means I'm x plus 1 all cubed, and I've gone up 2 units. So there's my general rule. I need another point, and there it is down here. X value, y value. So -2 is equal to some A, 1 plus 1 cubed plus 2. Take the 2 across. -4 is equal to A times 2 cubed. So -4 divided by 2 cubed, which is 8. A is equal to -1/2, which is what we were hoping for. Y is equal to -1/2 x plus 1 all cubed plus 2. All right, so the negative, which matches off with the quadrant that we're in. Now let's just scoot back up to example 14, because example 14 is one of those ones where we've just got information. Okay, so in other words, at x equal to 1, y is equal to 0. At x equal to 2, y is -7. At x equal to 3, y is 27. At x equal to 5, y is 80. So my equations, all right, if I'm going to do this, this is typically going to, as I said earlier, this is going to be a CAS question. But let's set it up first. So I'm going to say f of 1 is equal to, substitute 1 into this. So I get a times 1 cubed plus b times 1 squared plus c times 1 plus d. And that's equal to 0. So that means I get a plus b plus c plus d is equal to 0. There's equation 1. Equation 2, f of 2 is equal to a times 2 cubed plus b times 2 squared, c times 2 plus d, and that's equal to -7. So I get 2 cubed is 8a plus 4b plus 2c plus d equals -7. Equation 2. The third point, f of 4. So f of 4 is equal to, what's that? A times 4 cubed plus b times 4 squared plus c times 4 plus d, and that's equal to 27. So 4 cubed is 1664a, 16b plus 4c plus d equals 27. Equation 3. And then finally f of 5. Gotta love that. A times 5 cubed plus b times 5 squared plus c times 5 plus d, and that's equal to 80. So 5 cubed is 125a plus 25b plus 5c plus d equals 80. There's equation 4. Okay, so now we would have to put that into our CAS, and I might put another graphic up just showing us what the solution would be for that. If we go down to the bottom now, and we'll just increase our magnitude a bit, we can see that I've done the same thing on the CAS, except this time I've just changed the equations slightly so that we can have, instead of having to write out a plus b plus c plus d and evaluating everything, I can just put in f of 1 is, I define the function. So you can see there, define the function on the calculator, making sure I use a time symbol between each of the terms, and that will generate the equations for me. All right. And so then you can see A is 1, B is 1, C is -17, and D is 15. All right. So that kind of question is only ever going to be a CAS assisted question. All right. So put the equations in, make sure you get the answers that they suggest, and work through the rest of 6H.